Hi, Assalamualaikum. My name is Nurauni binti Rosmi. My metric number is 198502. So in this video, I'm going to continue to explain the method that I have learned. Okay, firstly is the integrating factor. Equation is y prime plus tangent of x y equals to cos power of 2x, which is firstly we're going to form it into this form, dy over dx plus pxy equals to fx. As we can see from this equation, it has been formed into this integrating factors form, so can just change y prime equal to dy over dx. Next, we're going to find Vx, which is the integrating factor. Vx equals to exponent of integrate px to respect to dx. So Vx equals to exponent differentiate tangent of x, because we have found out that from original equations that px is tangent of x. So after we integrate, we have found out vx equals to sec of x. So next is step 3, which is we're going to multiply vx, which is integrating factor, multiply with the both sides of the equation. So after we multiply it, we have found out sec x y prime plus tangent of xy equals to cos x. And the last steps, we're going to integrate this d over dx, y sec x equals to cos x. Integrate the both sides, and we have found that y sec x equals to sec sin x plus c because this is unknown. So after this, we're going to continue with the determinations of the integrating factor. We're going to continue with the third method, which is Bernoulli. Bernoulli actually is same with the integrating factor, but Bernoulli is for non-linear one. So if we got non-linear, we're going to change it to the linear one, which is the integrating factor. So as we can see from this equation, this is the non-linear one, dy over dx plus y power of -1 equals to x squared ln x. So this is the non-linear. We're going to change this form into the linear one, which is the integrating factor form, which is dy over dx plus pxy equals to fx. So how we're going to change it? By let v equals to y power of -1 and dv equals to -y power of -2. So we substitute this one into this equation. We have found that dv over dx minus 1 over x v equals to -x ln x. Next, we're going to find integrating factor by vx equals to exponential of integrate px dx. So from the equations before, we have found out that px is a 1 over x, -1 over x. So we integrate -1 over x towards dx. We have found that integrating factor is 1 over x. Then step 3, which is we need to multiply the integrating factor with the both side of the equation, which is 1 over x multiply with dv over dx minus 1x v, and integrating factor multiply with x -x ln x, and we found out that the answer is -ln x. Then I'm going to integrate this form, integrate the both sides, Then after we integrate, we're going to get the answer in the form of v, but the question is in the form of x and y, so we're going to change it to the original one, which is in the form of xy, by substitute v equals to y power of -1, which is we get this from the first step. So after we substitute v equals to y -1, we get 1 over xy equals to negative epsilon x plus s plus c. So we have done with the Bernoulli's differential equation. Okay, next we're going to continue with the second method, which is determinations of integrating vector. Okay, the question is xy plus y dx plus x plus 4y minus 2 dy equals to 0. From this equation, we can identify which one is msy and which one is nsy. As usual, the first one is msy and the second one is n. That is a sequence. So from m, we're going to integrate, going to differentiate towards to y, which is equals to x, and n we're going to differentiate towards to x, and we're going to find out 2x plus 4y minus 2. So this is my mistakes for y actually. And then differentiates toward m towards to y and differentiate n towards to x. We need to minus it, and we're going to find out this answer, and we're going to multiply this one with 1 over n. Actually this one is not fixed. We can multiply it with 1 over m or 1 over n. We can choose it so that we can have the simplest answer. So this one I choose 1 over n so that I can get this answer is 1 over x minus. Then we're going to find the integrating factor by this formula. Exponential of integrating px over dx equal towards to dx. So we're going to integrate minus 1 over x, and we get this. This is the integrating factor. Then we're going to multiply the both sides of the original equation with the integrating factor, which is v or vx. After we multiply, we have this equation. We get this equation, which I name it as an equation of 1. Then we're going to make test of exactness, which is differentiates of m towards of y equals to integrate differentiates n towards to x, which is -1. So this is exact. Then I'm going to differentiate f towards to x, this one. Differentiate f towards to y, x plus 4y minus 2. Then we integrate this. We're going to form this one, xy plus ln x plus gy. Then we're going to differentiate f towards to y, and we got this. Differentiate f towards to y, we got this, x plus g prime y. Then we're going to compare this form with this form. So g primes equals to 4y minus 2. So gy equals to 2y squared minus 2y. Then we're going to substitute this answer into f equals to xy plus ln x plus 2y squared minus 2y, which is equal to c. So determinations of integrating factor have done.